So it looks like today we're talking about the uh, the second day of the light note guide here, and it goes back into Snell's law. Looks like I've got some space to talk about those people I talked about actually the day before here. And then here it actually just talks about different various vocabulary words that relate to light. And so maybe just kind of take a look at some of these vocabulary words and make sure you understand the difference between these guys. Okay. So what we're going to talk about, we're talking about like diffraction right now. And that's basically when light ends up going through a sort of you can get a straight wave front that comes in and hits, it would be called a slit, or like a little sliver of between two, things here, pieces of plastic or metal or something like that. And how does the light end up going through? Does it go through perfectly straight like this, and you end up with, over here, a, kind of just a little dot of light? Is that how that works? Or does it like sort of start to reflect and things? And so as it turns out, it gets bent around these edges here, okay? Like this. And the wave fronts come out like this, all right? Now, the question is, well, what happens if you've got two of these little slivers, right? One and two next to each other. What happens is you get a sort of wave fronts that come out like this, and then I'll make these guys in different colors. And then you've got wave fronts that come out like this, right? And on more or less page 2 or 470, there's a nice drawing of this. Now remember that these are wave fronts, and so these lines are actually crests, okay, of your wave form. So crests, right, of your waveform. And so there were two lines would be, two adjacent lines would be two crests, and there would be a trough in here, kind of like this: crest, trough, and so forth. So the green lines and the red lines have that scenario. So what happens is, it turns out, as you get two crests that happen to be at the same exact location in space, the light is brighter. Okay, and as you get two troughs as well at the same location of space, the light is brighter, because two troughs will intensify with each other, and two crests will intensify with each other. So that would be, for example, like right here. This is a bright little area. Then I got two crests here, and I got two troughs in here, and so forth. Now, what happens when you've got a crest and a trough at the same location? You actually get a cancelization of light. So that would be something along right here. You see how I've got the red line has a crest, and the green light should have a trough, right? And then same here, I've got a crest on the green and a trough on the red, then a crest on the red and a trough on the green, right? And so forth. And so these end up sort of coming out, these dark areas, they end up coming out like this, right? And spreading out like that. Now, if I were to put a sort of a piece of paper here so you could see these things, this one, where it would hit, notice these are all locations, right? So I'm going to talk about these orange little dots now. They're all locations where you would have a crest and a trough being at the same location. This would end up being dark on the piece of paper. And then all of these locations where you have crests and crests or troughs and troughs would be light or bright, I guess I would say, on the paper. Okay? And so it would be bright and dark, bright and dark, bright and dark all across the paper. Okay? And as it turns out, it does happen this way, right? And so as a result, you get this double slit experiment. This is what this guy, Young, came up with, which is, they say, considered one of the most important experiments in physics history, right? So, anyway, so now what we've got here is, so you can go ahead and read all this stuff. Basically, here it is. Here's a diagram, a little bit more simplified diagram. You shine your light through here. You got two slits, and what happens is you get dark spots and dark spots and bright spots. Now, in terms of the vocabulary, the bright spots are oftentimes called maximums. That would be here, and the dark spots are called nodes. And then there's something called the central maximum, which occurs right across from the center of the two slits. Okay. All right, so you can kind of read all of this stuff, right? And so our goal here is to sort of understand why this happens, right? So the idea is that they're waves, and two waves that interact with each other at a crest and a trough end up canceling each other out. And so therefore the same thing happens with these with light, and so you get a dark spot here. Okay. Now, what we're going to do is, this is that guy, Huygen, right? And he, you know, I had an animation in here, but I think it's not working. Anyway, so what we're going to do in this area is we're going to talk about the geometry of this, all right? And we're going to develop a few equations here, okay? So here's our equations, all right? And I'm going to go ahead and write these equations. Oh, well, they're written here, right? They're written in this area. I'm going to go ahead and explain them right here, all right? I'm going to give myself a little bit of space. Hang on here. I'm going to pause.